In this lecture, we're now going to take a look at cloud economics and scalability, also just some fundamental terms you need to know about cloud computing as we get further along and then get deeper into GCP itself. So to begin with, economies of scale is the ability to do things more efficiently or at a lower cost per unit when operating at a larger scale. So think about the cloud benefits this provides. For one, cloud providers can pass on economies of scale to consumers. So again, they've got that large purchasing power. They're buying up, CPU, memory, disk. They're really good at power and cooling. Just think about all the resources you need, especially as a small business. If you wanted to start up, various services or maybe have your own data center, that would be very, very costly. You would have to rent premises. You would have to get people that can maintain that. You've got air conditioning and everything to think about as well. All of that's got to be taken care of. And so there's a lot of benefits here just from, the cloud providers taking on that responsibility and sharing that out to the consumers. They can acquire hardware at those lower costs. They've also got things like local government deals. So for example, the local government may give incentives for them to employ people locally. They may give them, just cost incentives, for power and things like that in that area as well. And that's why you sometimes see in cost calculators between different regions, sometimes it's a little bit cheaper somewhere because they've got a better deal and they're able to run the data center at a more cost-effective price somewhere. And that also comes into data center efficiencies as well. Again, economies of scale, Google's going to be really, really good at managing data center. They've had years and years of doing this with their search hardware, and now they're really, really good at it with GCP as well. It's also very important to think in terms of CapEx versus Opex as you're having cloud discussions in your business and talking to perhaps your CFO about how the costs of the service you're trying to provide are recognized in the business. So we've got CapEx on the left-hand side. CapEx is capital expenditure, and this is where we spend on infrastructure up front, and we can write off our costs over time, versus Opex, where we don't really have those upfront costs. We pay for the service as we consume it, and we deduct from our tax bill in the same year as the expense occurs. The big difference being, again, the upfront costs. We don't have to spend a lot up front when we're using things like GCP. We can simply say, hey, I want to use that virtual machine. I want to try something. Perhaps I want to do something with data. I can consume that service. I don't have a huge upfront cost. I can try it out, fail fast if I need to, and move on. With CapEx, I'm saying, hey, I've really got to justify this big investment before I can get started. And if you look at some typical on-premises CapEx costs, it's things like the server costs themselves. They can be very expensive. The average server was typically around $10,000, upwards from there. Sometimes you had smaller ones too. It just depended on the performance you needed. But for a lot of these VMware hosts, they were very, very expensive. Obviously, they had a lot of CPU and memory in them, but it's not cheap to do. You then have storage costs that you add on top of that. You've got network costs. You've probably got teams that have to admin all these as well. We've got backup and archive costs and data center costs, including DR as well. The people costs would be more on the Opex side. This is really focused on the CapEx cost to buy the equipment that we would want to put in these data centers. Typical Opex costs for cloud computing are the server lease costs, the software and feature leases, and usage demand cost scaling. Some of those would apply on premises as well. So just think, Opex and CapEx, think of recurring costs or more your operational expenditure, and the fixed sort of upfront capital purchases are really your CapEx there. But really it's all around usage demand. On demand is a lot of Opex for server lease costs and services we would consume from GCP. Benefits comparison, CapEx benefits, predictability, right? You pay for it, you've paid up front for it, it's cost effective when you can consume the infrastructure quickly. So sometimes it is still cheaper to run on premises if you're buying up front and you're going to consume that hardware very quickly. Often good reasons to do that. Opex benefits, try and buy, lower initial costs, demand fluctuations, so anything variable, seasonal. A lot of these modern architectures based on containers and serverless functions, huge benefits with Opex there. The next thing to think about really is scalability. And when we think about scalability, think about increasing or decreasing resources based on workload demand. And you'll hear the terms vertical and horizontal scaling. Vertical scaling is really around scaling up and potentially down as well, but adding additional resources to increase the power of the workload. And a great example of this is adding additional CPUs to a virtual machine. So think about going from 2 CPUs up to 4. I've got the same workload, the same node, the same virtual machine, but I'm throwing more power at it. Horizontal scaling on the flip side is known as scaling out, and this is where I'm basically adding more nodes. So maybe I've got lots and lots of 2 CPU nodes, and let's look at it more from a graphical standpoint. If you look at vertical scaling, that's where I'm basically making the machine I've got bigger. This is a GCP compute engine logo that you're seeing there, and then with horizontal scaling, I'm basically adding more nodes. So instead of making that machine bigger, I'm adding more nodes and spreading the load around them. And it's a key concept, particularly in cloud computing, because with operational expenditure, it's better to scale up and down in a horizontal fashion. So I'm adding and reducing more nodes versus perhaps just throwing more resources at a node, which can become much more costly and sometimes much harder to take back those resources when you want to in the future. If you look at this as well, this is one of the diagrams that comes from the definitions for cloud computing, and you can see static scale in there for an experienced workload versus IT resources. And if you look at the black bar in static scaling, that's steady across the top, and then the workload is kind of going up and down, but it's got a steady amount of resources. With elastic scaling, it's basically going up and down in response. And this is the concept of elasticity. This is a major pattern which benefits from cloud computing. As your workload changes, resources can be changed to compensate up or down, and that's again where you get some cost benefits there as well. And a good example of this is seasonal demand for retail website, again like a Black Friday or something, lots and lots of traffic. Hey, it's not going to be cost effective for me to build all those resources in up front just for one day where we have peak traffic. I can basically use elastic scaling to automatically respond to the demand for that service. And with that, that concludes this lecture on scalability and elasticity. And next we'll move on to the cloud service models, and we're getting very close to jumping in and getting stuck into GCP, but we just need to cover some more of these core concepts first of all.